All right, good afternoon, everyone. We had a little bit of technical difficulty there, but good to be back. So hopefully you all are doing well today. My name is Jen, of course, and we are here for our online academy from good old Long Beach, California. And we're very excited today to talk a little bit about ocean exploration. Now you're like, wait, you said your name's Jen. Why are you saying we? That's because I am joined today with Dana, who is back behind today, showing me some pictures. And then we also have James, who is going to be taking some questions for today and passing them on in. So with that, if you do happen to have any questions, you are more than welcome to go on ahead and text us at the number here that Dana will be putting up shortly. But as we go on ahead and stream live, if you happen to catch us when we're no longer streaming, you are also able to email your questions. So if you're like, Jen, wait, how do we send our questions in watching live? Well, great question. You can go on ahead and text us at 562-286 1838. You'll see it right down here on the screen. And of course, if you are a younger viewer today, a younger ocean explorer, please make sure that you get your adult's permission, as texting rates do apply. But once again, if you're watching this later on when we are no longer streaming, you are more than welcome to still email us any questions that you have down below at live@lbaop.org. All right, so with that, what we're going to be doing today is just talking a little bit about how we explore the unknown. I know for other ocean exploration classes, we've had a chance to talk about, how do we get to know what's in our ocean, and how do we explore. And today we're going to be focusing a little bit on the mysteries of ocean exploration, of seeing unknown areas, which is actually most of our oceans have yet to be explored, and then mainly focusing on the deep sea today. Now, much of coastlines have actually been explored, though there are still some coastlines that are being explored. If you're wondering, well, how far out does a coastline go? Usually it goes out about 200-ish miles for our country to the continental shelf. So we have a little underwater ledge that goes, and then it drops off. And so that area is what we like to call our coastal regions right there. Now, there's still some coastal areas next to land that have yet to be explored, and there's much further out that, of course, needs a lot of exploration. So this is really exciting because what we're going to be talking about today is not just, what we know now and the information, but I mean, this is stuff that if you're a viewer, you can eventually contribute to this field. You can explore and you can maybe discover whole new different kinds of animals today. So with that, let's go on ahead and maybe think about, well, what do we know so far about the ocean? It's a really big question, right? You're like, well, there's so much that we know. I mean, we know that there's different oceans. We know there's tons of animals. We know there's algae. We know there's the depth, right? I mean, there's so much that we already know about the ocean that's hard to imagine that there is still more to explore and discover. And many times when you all write in questions about how many different varieties of squid there are or fish there are, we can give you a general answer, but we can't actually give you a very specific number because, hey, we're still discovering, we're still trying to figure out what's out there. Now, if we think long time ago, kind of back in the day of maybe some early explorers on, on some kind of like pirate ships back in the day, all those tall ships, a lot of them were kind of seeing the ocean like we're seeing it here, right? You can kind of see the very top, but it's really tricky to see anything that's really further down. And so a lot of sailors back then, and maybe some scientists that were aboard along those times, the way that they would try to figure out how deep they were was by taking something called a lead line. And so what that is, it's a huge chunk of lead, right, metal, attached to some rope. And I have an example version of that right here. It's much smaller, but basically you have that heavy weight and you have a rope, and at in this case, every fathom, basically every 6 feet or so, you could stick it down and you could have it go down, down, and down, deep into the water until, because it's usually pretty tight, until you hit the bottom and it goes kind of limp, kind of loose, right? Once you've reached that point, you can count all of these little notches right here every 6 feet or so, and you can go on ahead and figure out the average depth that you are at. And so they would constantly do that. If they were going near maybe like an island or maybe going to some mainland area, they would go on ahead and take the depth. So that way they would make sure that they wouldn't crash into land or any kind of, reefs that might be underneath. So that way the hull of their ship or of their boat wouldn't get scratched or they would sink, because that would not be very pleasant. And so that was the way that they were able to do some basic underwater mapping and basic ways of figuring out how they knew what used to be unknown, right? So pretty interesting. But with that, throughout time, we've kind of changed, right? We no longer really use that lead line, but we now go on ahead and use, well, what do you think we might use? Here's a nice example of a ship that we have here. How do you think it's able to make this picture that's down below? Well, if you go on ahead and you see this cone image right here, this is a way that we're able to figure out what the underwater ocean looks like. We use sonar, a type of sonar mapping that's not harmful to any animals, and at the level of the sonar that they're mapping, and it's able to create all of those different images. Now, underneath the water, it's not just plain flat. Maybe if you tuned into our sandy bottom habitat episode earlier, you might have noticed that was all really flat sand. But this time around, we are, the ocean isn't completely that way. And there are lots of mountains and valleys and everything in between when looking down in the deep ocean, or when looking in the ocean in general. So as you saw in that little video right there, right, it used sound just like echolocation. So like bats might use sound to figure out where they are, or dolphins might use sound to figure out where they are. We're able to use that similar kind of technology and figure out the depth of the ocean and what it might look like. So we call this kind of like the topography of the ocean, right? So basically, what does it look like? What features do we notice? And so as you can see here, you might be able to see that we have an underwater mountain that we have here. Now, if you notice that there's colors, these colors do represent different parts. I'm going to get out of the screen for a little, because if you see right here, all of these keys are about the depth that you can see right there. And so the depth, you can note exactly what depth they are, but you can also get a general ballpark idea by seeing all the colors that are located right up here. So if you think about a rainbow, kind of like the red, oranges, yellows are going to be a lot more shallow, so it's not going to be very deep. And then as you move on to the blues and the purples, those are going to be your deeper down you go, those deeper, richer colors. And so we use these bathymetry maps to paint a picture of what the ocean floor looks like, right? And so now that we have an idea of what that ocean floor looks like, we can now go on ahead and maybe send down different kinds of equipment or instruments to get a better idea of what is present. Now, that bathymetry picture is really cool too, because it also allows you to maybe figure out, hey, I notice there's a mountain there. I know that I've seen mountains in the past, and I know that maybe certain animals like to live in those certain kinds of underwater mountain ranges. Or I noticed that as we were mounting, I saw lots of little bubbles that were coming up. And I know that where there's bubbles, that means there's a very specific chemical reaction going. Or maybe I know that there's certain animals that like to live down there, right? So these different clues that we can get by just looking at the map of the ocean can then provide us with extra clues to maybe what might live down there. And actually, Gage, hey Gage, good to see you. Good to have you again. Can't really see you. That you can see us here at the aquarium is asking, what kind of animals can you find on the sea floor? And you know what, Gage, I'm super excited because that's some of the things that we are going to be talking about today are some of those animals on the sea floor. So we'll hold on to that question because that's really going to be what we will be focusing on today. Now, the only way that we're actually able to see a lot of these animals on the seafloor is by now figuring out how do we get from our ship, right, down to the sea floor to see what kind of animals live there. Now that we know what the actual bathymetry, right, what that sea floor actually looks like. And so we could do that in a variety of ways. Can you maybe think about some of the ways in which we might get a chance to physically, like, or to be actually able to see what's in the deep? Scuba diving could work. But then, when you're scuba diving, you can't be down for super long, and then you can't really go super deep because it gets really cold, and the pressure gets really intense the deeper that you go. So, I don't think scuba diving is really good for like super deep sea exploration. Other thoughts? Yeah, maybe submarines, right? So maybe you could stick a person in a submarine and down you go to explore. But eventually, those people may need a snack break, which they may bring some snacks along with. They may need a bathroom break, right? And humans can only maybe stay down for a certain amount of time. Now, a way that you might be able to stay down even longer to explore. Here's a great picture of a submarine that we have right here, where people are inside. And it looks like you can only fit 2 people. So maybe the pilot and maybe a scientist. So maybe we have 2 folks that are going down. Looks like there's a nice camera or maybe some lights that are attached that may help our submarine go, right? So that's definitely a way that you can explore. But other ways, if you want to go like super hardcore about it, you may use something that you can use remotely from the boats. Now, if you're thinking ROVs, you are absolutely right? These remotely operated vehicles are a great way to where you don't have to put any humans in there, but you can sit nice and dry, right, in the ship, and you can use kind of like a remote control to then be able to drive this large ROV down into the deep to be able to take samples. Now, the depth really does vary, but I know about on average, some of the ROVs can go like 4,000 meters. Others can maybe go up to like 6,000 meters max. Now, the entire deepest part of the ocean is about 10,000 meters, just to give you a reference. So it's crazy to think that some of these ROVs that we have right here, really can only go down almost half of the way. But if you look at it, what do you notice? I see some lights. All these lights are being illuminated down. Looks like it's a shipwreck right here, right? So ocean exploration not only talks about animals, which are pretty great, right? Also focuses on maybe geology, archaeology, history, a lot of different reasons to why we might explore the deep ocean today, right? And so if we think about as we explore, let's see if we can, Dana, maybe pull up another ROV. Awesome. And as we do so, looks like we have a question. I see we have an animal question that we will get to in a little bit. I appreciate how many of you are just chomping at the bit to talk about animals. And so as Dana's kind of looking around, I don't want to quite talk about animals because then that means she has to put another picture up. But some of the animals, just to give you a sneak peek that we will be talking about, include the bobtail squid. If you joined James earlier today and talking a little bit about squid and watching that squid dissection, you may have noticed that we had a few bobtail squid questions and we talked a lot about them. And so I'm really excited to be able to share that with you. And so with that, ROVs, right? Here's a great example of one. Thank you. And so what we have here, this is only one of actually 2 ROVs. So many ROVs work in tandem with each other, meaning that there's 1 and then there's 2, and number 2 is attached to number 1, and number 1 is then attached to the ship, right? And so that's for a handful of reasons. One is if you think about the ocean, it's very rocky, right? Even on a calm day, you might be moving back and forth and up and down in the water, right? And as you're trying to take a sample or look, at something, if you're constantly moving up and down, that makes it really tricky, right? As an ROV pilot, you might be really tricky to be watching something swing up and down all the time. And if you're the person that's using mechanical arms to sample stuff, it can be really hard if you are slowly moving up and down. And so these ROVs work together. The very top one that's attached to the boat actually deals with a lot of that up and down swaying motion. And then the ROV that's down here, that's tethered to this top ROV, can then have the freedom to move however it wants without any of that up and down or side to side kind of motion, because that first ROV is taking all of that movement. Now, another reason why it's really cool to kind of have that tandem system is that the top ROV can shine down and look onto the bottom ROV to make sure that positioning is right? Because as we saw earlier, that mountain, I mean, that might be really tricky to be able to drive around. So the two ROVs work together to make it happen. So here's a good picture of kind of that top-down view where we have, this is taken from the ROV that's on top, that's connected to the actual ship. And then from there, you can see that tether right there, which is about this thick or so, actually. And then that tether has all sorts of different wires and is wired on into the other ROV that you see here. So that way they can kind of work together. In this case, check out this really cool shipwreck. And so, yeah, we do have a question about how big are ROVs, and they are about the size of like a really kind of large car. They can be about like 7 feet tall, and they can be about as wide as a car is, or as long as a car is, if not maybe a little bit longer. It kind of depends on the ROVs. I know Argus, the one for Ocean Exploration Trust, it's actually a lot more squat. It's a lot shorter and it's really long. Versus Hercules, the one that we just saw in the last picture, is actually really tall and it's more boxy in shape. So they definitely can vary depending upon their use. And another question that we got about ROVs is how many people drive the ROV? And that is an awesome question. So a lot of times when you're out exploring, it depends on the vessel and how long your expedition that you're out exploring the ocean. But there's lots of shifts that are on the boat. And so a lot of times you'll work like a 4-hour shift, and then you'll have about 8 hours off or 10 hours off, and then you'll be working another set of hours. And so here's an example of a control room right here. And usually there's at least one ROV pilot for each ROV. Now, they're not working alone. A lot of times they're working with a navigator as well. So you can see here all the different screens. And a video engineer is also working with them. So you can see the controls right here. The video engineer is actually the one that helps kind of control a lot of the imagery that the ROV is seeing. Then there's a navigator that works with the captain of the boat. And this navigator also works with the ROVs to make sure that everyone's talking and coordinating with each other. Because even though these ROVs are out on a really big, long, almost like a leash basically, if they're moving and they're checking out a new location, it's very important that the boat moves along with them so they can explore a much larger area. Now, these ROVs can actually stay down for up to 3 days. At least that's one of the longest times that the Nautilus has had their ROVs down in the water. And so there's a shift change every 4 hours. There's about several shift changes that go on. So on average, on a boat, you may have about 6-ish ROV pilots that are present, but there are also interns too, which is pretty cool. So that's something to kind of take in consideration too. But definitely an ROV pilot for each of the ROVs, and then that changes several times as it's a 24-hour working time that it happens. So it goes through several shifts before they get that first ROV pilot back on. So pretty interesting. Dana, could you bring up the video that shows the launching of the ROVs, please? So we have a time-lapse video that Dana's currently looking for that shows the deployment of the ROVs, because it is kind of interesting to be able to see how you kind of deploy 2 of these ROVs around about the same time. But in the meantime, as she is looking, we do have a few more questions in. So thank you so very much all for asking. Do only invertebrates live in the deep ocean? Believe it or not only invertebrates do. Because I know, right? You're like, bobtail squid, so cool. But aside from the bobtail squid, we do have a lot of other animals. Let's check out this video and then we'll talk all animals. All right, so here's a little bit of behind the scenes where they're launching Hercules and Argus together. So if you can see here, this is the one that's attached to the ship, and so that's Argus, and then this is Hercules right here. And Hercules will, as you'll see, goes into the water using a crane arm, and so that's the first one that's in the water. And Hercules is then attached to Argus right here. So you'll get a chance to see Argus finally going out, and that's how they're actually able to launch. Pretty cool, right? So that was much faster than what happens in real life. But that they're so large, and hopefully you had a chance to also see the scale of the ROVs in comparison to the people, because they are much larger than the people. So let's go on ahead now and talk a little bit about animals, because there are more than invertebrates. Many times there are sharks that live kind of in that deep sea environment. There's also a lot of fish that live in that deep sea environment, but there are also a lot of wild and wacky invertebrates. So let's go on ahead and maybe pull up the bobtail squid, because that one is pretty awesome. Awesome, thank you. So with this bobtail squid, isn't it adorable? I love this squid. It is absolutely cute with its big eyes, and it looks like it's just a very rotund or very round animal, but it's what it normally does is actually hides underneath the sand. Now, even though it looks giant here, it's anywhere on side, it's usually about like less than 2 inches. So if you think about your thumb and that being about 2 inches, it's maybe about like an inch and a half thereabouts. So it's really tiny. So you see this little like nub that basically sits directly either on top of the sand here, or a lot of times will bury itself underneath the sand. Now, why does it bury itself? Well, because it actually sleeps in the sand. This animal is a nocturnal animal, so it likes to bury itself into the sand during the daytime and then comes out and hunts during the night. Now, we've been talking a lot about deep sea, but these bobtail squid are found anywhere from really shallow waters, like this one here, which is I think this one might be the Hawaiian bobtail squid. I'm not 100% sure. But there's also other bobtail squid that live in the very deep sea. So there's lots of different kinds. But with this Hawaiian bobtail squid, there's a little bit more known about this one. Similar size to the deep sea one, if I'm not mistaken. And with this Hawaiian bobtail squid, it is an ambush predator. So it will sit in that sand during the daytime, and it will actually build up a symbiotic relationship with bacteria that are in there. Now, if you went ahead and you viewed our last class, our squid dissection with James, you may have heard some of this information. It may be familiar, but for those of you that haven't, these squid have a special relationship that benefits a lot for the squid, but also for the bacteria. So these squid will have bacteria in them, and it'll develop and reproduce overnight. And when nighttime comes, the bacteria starts to glow, and it actually is almost like an alarm clock for the squid, where the squid will kind of wake up. From there, the squid will use that bacteria, and it will kind of match the very moonlight that's being shined down directly on top of its mantle or its body that you see right here. And so it's almost like a cloaking device. You're practically invisible, which is pretty amazing. And so with these squid right here, you can imagine them kind of glowing really hard to see. And as I mentioned, they're ambush predators. So they will glow, they will move, and when they see their food, right, they'll go on ahead, eat it, hum, yum, 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 and have a lovely, tasty meal there. One of their favorite snacks is actually shrimp, because you can imagine an animal that's only about like this big, right, kind of flying through like a little bee. They have to eat small things. So many times they'll eat super teeny tiny fish. They love to eat worms, but their favorite thing to snack on are like, really teeny tiny shrimp. They like that juicy, sweet, crispy meat that's there in those shrimp. So, these animals are quite incredible in their relationship with a lot of this symbiotic bacteria. Now, what else is really cool is that a lot of times they will expel or shoot out about 90% of that bacteria before they go to bed in the morning. And then that bacteria, that 10%, will slowly regrow and recharge to what the bobtail squid will need for that next night when it wakes up and it starts hunting again. Now, what else is really cool about these, can you tell that I'm a fan, is that these bobtail squid, because of their cloaking device, almost like natural cloaking, is so cool that the US Air Force is actually really into it too. They're like, wait, there's a squid that can cloak itself? And so they're very interested in finding ways to camouflage their aircraft. And so it's kind of cool to see, nature be an inspiration. So very cool animal, that bobtail squid. And hopefully our viewer Stewie there has now learned a little bit more about bobtail squid as well. All right, another question came in. What is the best color to camouflage in the deep ocean? Oh man, that is a great question. So if we think about it, the bobtail squid here, even though it's kind of shallow, right? A lot of the animals that we see in our ocean are either maybe white or maybe purple or maybe red in color. Any thoughts to why that might be? Well, let's get a glimpse into what that deep ocean will look like, and maybe that will help you figure it out. All right, so let's take a look. Huh. Looks pretty dark, doesn't it? And you got it. You can't really see any colors because our sun doesn't actually penetrate down to the depth in which we're talking about the deep sea. So sunlight can only penetrate about 200-ish meters or thereabout. But most of the production that happens is usually much more shallow. It's within the first 100 meters. And so when we're talking about deep sea ocean, we're thinking like maybe hundreds to thousands of meters deep, where all of the wavelengths just don't get a chance to penetrate down that deep. And so these animals, even though they are red, bright red, or purple, they're actually camouflaged down there, believe it or not. So it's pretty incredible. So thank you so very much for asking. And Sophie is asking, why don't ROVs get crushed by the pressure? Oh man, yeah, right? Like as mentioned before, there's so much pressure that's put on anything that goes down to these depths. And the ROVs are made up of very special materials. I don't know the exact material off the top of my head, but they are made of such special material that enables them to not get crushed. But all of their equipment has those similar challenges. So whatever technology that they choose to put into these ROVs, it also has to deal with all of that pressure to make sure that it doesn't get crushed as well. So it's really challenging being an ROV pilot and an ROV engineer as to really be able to make sure that everything can stand the pressures and everything that the deep sea has to offer. So that is a great question. And you know what? Many of these ROVs actually are a little bit buoyant. So, if we talk about things that are float, that's going to be positively buoyant. This may sound familiar if you've seen any of Dana's scuba classes, right? So buoyant is where there might be floating, positively buoyant. Negatively buoyant might be where you're sinking. And neutrally buoyant is somewhere in the middle. And so ROVs a lot of times usually like to be just a smidge, I think it's negatively buoyant, just a little bit. And that helps them to be able to control the ROV a lot better. So that way they're just not, floating around and and dealing with the whims of the ocean. So thank you so very much for asking. All right, so we only have a minute left or so, but I just kind of want to recap a little bit about what we talked about today, right? Because it's exploring the unknown. So how do we go about doing that, right? Back in the day, sailors went ahead and used that big lead line with all of those little marks that help them to be able to figure out the depth. But we've come a long way since then, haven't we? Now we've developed that sonar technology that has really helped us to be able to see the ocean seafloor. We get to see all the mountains that are present, all the valleys, everything in between, seeing how flat different parts are. And then we know that we can now drop down different types of technology, right? Either it be scuba divers or submarines or ROVs. I mean, those are just a few technologies and we can send down to then be able to get a glimpse into some animals, such as our bobtail squid that we talked about today. So clearly, there's a lot more animals out there than just the bobtail squid, but unfortunately, we are out of time. So we will have to leave some more ocean animals for another deep ocean exploration class. But thank you all for joining us today here for our online academy. If you do have any questions and you're watching this, either just stumbled upon it now, or maybe you're watching this at a later time, you're always more than welcome to send your questions right on over to live@lbaop.org. And we look forward to answering any further questions that you might have. Thanks, everyone. Have a great rest of your day.